So the one in Elba, the one on top, Nilesh.
Okay. So here is my answer, and I have Daniel confirming that we will. Daniel confirms that we meet.
Are you guys doing it on the 12th or the 19th?
12, 12. I am going 12. I confused everybody about 19th without checking with my wife.
Okay, so did everybody get a promotional code from Krista in the email?
I got it, and like before Nilesh posted, I bought it for 19 because everybody was saying 19.
I know.
So
Oh,
I think
You
I
can
got
you
it
can
no.
for.
still change. By the way, you can still change. There is time. There is lots of seats. You can relinquish the ticket you have and get another one for the other date, 12th. If you can make it, you can still do
I
it.
doubt it.
Is it the same promotional code for everybody?
The
Yes.
code is same. The code is different from each date, but the code is same for everybody.
Okay, so I'll post the 12th code on the classroom right now.
Okay, yeah, I won't be able to make it for the 12th.
I won't be able to make it for 12 too.
You can
But I
always,
still gonna go on 19
yeah, I
though,
think you can always go on
by
the 19th.
myself.
Yeah, we will miss you. I'm sorry, but
Yeah, it's
yes.
alright.
Who's going on the 19th?
The chin.
Aha, that's what I'm gonna go to.
Okay, I'll see you there.
Yes, bring my wife and kid.
Okay.
So you're not going to be there either tomorrow, Aaron?
Nope.
Oh.
Is it tomorrow?
It is
Maybe I'll
tomorrow.
just go then too.
Oh.
Maybe I'll double dip. But I told her I was gonna take my wife and kids, so I'm definitely gonna do that. But I'll it's tomorrow?
Hey, Nilesh, quick question.
Yes.
Hey, I looked on the website for the theme, but it's still not showing up there anymore.
I think we should do that after this call. We should fix that issue. I think I did fix it again, but maybe I did not succeed. I'll check at that, look at that at 12 o'clock after we finish with this conversation that we have to begin now. Is that okay, Brian? Brandon?
Well, yeah, we'll have to look at it later because I got a doctor's appointment.
I see.
They'll leave for at 11 o'clock.
Makes sense. Makes sense. So I'm just sending this email out to you so you know which location we are meeting tomorrow, and also you can. There are two different coupons for the 19th as well as 12th. So I'm.
What are the codes?
Yeah.
I'm posting it in the classroom right now as we're speaking.
Look, there is a
There you
Yeah,
go.
whenever.
different code
So
for
it's
12th, different code for 19th, two different codes. I cannot use
so
them. You can.
And when you drive into LB, I mean, it's a very small town because they go hunting
You
right
can't
outside
miss
of
it.
there. No, you drive in and the train is right on the right as soon as you drive in. I mean, the main strip of the town is less than like 15
block.
buildings.
Yeah, it's
Yeah.
like a block
Yeah.
long, and that's it.
Yeah, and
When
the
you
train
drive
takes up the
in,
entire
you'll
right-hand
see.
side.
Yeah, you'll see a bunch of cabooses set up. They have like a little motel where you can like stay in a caboose. So if you just look on the right hand side, you'll see railroad and a bunch of different colored cabooses.
The restaurant there is really good, also.
Yeah, it
is
is.
Yeah,
it
that's what
north
I've
or
heard.
south of JABLM?
It's
It's
east,
south. Well, southeast.
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 Yeah.
Okay.
Depending on where you're
It's-
coming from.
Do you know how to get to
You
Mount
can-
Rainier? So you want to take Highway 12 up.
Yeah, like I'm okay.
You want to take Highway 12 up, and it'll bring you up through. Do you
Morton,
know where
probably.
Mineral is?
Huh?
Do you know
I'll look
where-
it up.
Yeah, you'll be coming up the opposite way.
Okay.
Yeah, anybody from Puyallup can just take Meridian all the way out to Eatonville, and then you'll take a left at the T, heading towards Lake Alder. You'll see it.
Yeah,
It's easy.
it's really simple.
So there are some questions in chat about how do you drive, and some people signed up for 19th, and that's okay. There are two distinct codes for 12th as well as 19th. The codes are same for every person, every veteran. They do not apply to non-veterans, do not apply to me. And I bought the tickets. You can get for free. I think it is. The question was, so we get one free ticket. I don't know, one or more. But if you put that code in, it will tell you what it can do and cannot do. And
Has anybody bought more than one?
I did.
Because I know Stephanie, or whatever her name was, said that, we could bring our families and stuff.
Yeah, Krista
Yeah,
did
that's
say.
what Krista told me as
And
well.
Krista.
Yep. Krista did
But
say.
has anybody bought more than one ticket?
No, I think if you just use the code, that you'll be fine. Because I was gonna get me and my wife,
I think the
and
code
then
is
I don't know if you
applicable
need
to
a
you.
ticket for like people under 2.
I think the code is applicable. You guys can use it for your families. I cannot, and you can. You can buy for veterans and families. I think it is applicable to you, so you can use the coupon. I don't exactly know how to use it, and you should be able to figure it out. So it is possible for you. It is meant for you. The whole trip is meant for you. So it is. You should be able to figure out a way to use and apply for veterans. So let's begin. Let's begin our conversation, which is a recap. And if
Where's
you
the code?
code is on Classroom, somebody posted apparently. Daniel.
Oh, on the Classroom, not the group chat. Got it. Cool.
Yeah, code is on the Classroom, so you can see it there. Now I'm going to turn off my video and continue my screen sharing. Just quickly checking. You're able to see my screen, are you?
Mm-hmm.
Was a yes, right?
Yes.
So in India means no.
Uh-huh.
Okay. So it's also another funny thing. This and yes and no, the way you shake your head in India is different. You may have heard of it. So
Yeah.
Sachin says yes. So yeah, the way Aaron is moving his head is a yes. It's kind of strange. Throws people off. Throws people off completely.
It's weird.
It is weird. And that's what I have seen people do in spite of living in this country for 20 years. And that's strange. But let's begin. Let's begin the conversation. So here I am with a whiteboard. And I'm going to say hello. And I'm just checking if you can see it.
I see your little pen moving around.
No, I didn't see anything.
I just see a gray screen and this little blue pen moving around.
Does it write?
Yeah.
Does it writing anything?
No.
Nope.
It looks like it should be.
Okay. Let me make the pen width a little.
Yeah, I don't even see the blue pen.
Yeah, I only see the gray screen.
How about now? Do you see it?
No, just gray screen for me.
Yeah, that's all I got is gray screen.
Okay, that means the pen is not showing up which is fine.
Oh my God.
Okay, the plan B. Plan B is like this. Do you see me typing?
Yes.
Okay, sweet deal. We'll use this instead. We don't have to use the pen.
Yeah, we're good.
No,
What? No.
I didn't see anything.
Do you see me typing?
Nope.
Do you see it?
Yeah.
Yes.
Okay.
Do you see me typing? Hello, how are you, Sachin?
Yes, that's
Yes.
exactly what
I can see the screen, but nah.
Yeah, I will. What I will do is use the keyboard instead of my pen, which does not seem to be visible. So I will skip the pen, use the keyboard and a black notepad, and I will use that to begin our discussion.
Okay, I see.
Okay, so the discussion essentially begins with this core concepts of basic sciences. I'll probably it is rudimentary for some of you, probably many of you, but that's where I want to begin today. Very basic sciences. When we history of science. People think the elements in the planet Earth are air, water. If you remember this discussion, fire. What was the other two? Sky. And what was else? What else?
Earth.
Earth. Right? Those were the basic elements that people started studying and understanding where things are coming from. And it slowly evolved into the periodic Periodic table of elements. If you remember that thing, do you?
Mm-hmm.
Yep.
Yeah. So let's look at what periodic table of elements is.
Hydrogen, helium, lithium, beryllium, boron, carbon.
Exactly. So here is the periodic table, and this is it. This is what it looks like. So most objects, most things on the planet, or actually the universe, are made out of these things essentially. So if you look at this hydrogen, take two of them, and then you look at the oxygen element, which is here, take one of them, you put them together, something like HO.
That's flammable.
That forms water.
It's very, very flammable.
Right. So you get HO and you call it H2O, right?
When
Yep.
in
That makes water. So that's how the whole construct, the entire universe is constituted of these known elements. Most of these elements are natural. Some of these elements are created by man. People created them. They are artificially constructed. They are artificially constructed elements. Some of these actually decay and convert into other types of elements over time. The decaying elements are called radioactive elements. You may remember that, right? So if this is not familiar, let me know. But at any point, if you do not remember anything, I would like to brush up. Okay, now let's identify some of the common elements used in computers. Which are those? Can you tell?
Silicon.
silicon,
Where is
yeah.
Lithium.
Here.
Gold.
Here, silicon. That's the most
Gold,
dominant
for
one.
sure.
This one. The most dominantly used element is called silicon. Yes, gold is used. Yes, copper is used. And yes,
Yep. Silver.
silver is used, and a whole bunch of other things. Lithium is used, and
Lithium,
lots
yeah.
of other plastics and all that. Plastics are mostly carbon. This guy, carbon. That's where power.
Yeah, lead is used too,
Lead
right?
is also used. So dominantly, the electronics are created out of this element. This is the reason why the valley area in south of San Francisco is called the Silicon
That's
Valley.
what I said. Yeah. Silicon Valley.
This
Yeah.
is the reason why it's called
That's
this.
why they're going to name their own state out of it.
Yeah. So it's the Silicon Valley. That's the reason that it's called a Silicon Valley. Now, in precise terms, if you take silicon and put another oxygen and another oxygen, what does it make?
SiO2.
What is it called? What is that thing?
Silicon dioxide.
Yes, but what is that thing? The object.
It forms. I don't know.
Silicon disc.
Oh, sand.
Yeah, the sand on the beaches.
Oh, chips, right?
No,
That's
no,
how
no,
they
no,
made.
no, not chips. It is the sand that you find on ocean beaches or sea beaches. That is SiO2. Okay?
Okay.
So silicon and oxygen and one more oxygen put together to constitute SiO2, and this thing is what we know as sand. Exactly this. You know what I'm talking about. This in desert, all of this is mostly silicon dioxide. Like this is what I'm talking about. You get the picture. Now let's move. Yeah. Okay. So now these chips that we have, silicon chips, these things, they are not sand. Okay. These things are made by people. They are not sand. They
Okay.
are not sand at all. They are just silicon. Okay? You got that? They are silicon wafers.
Okay.
Silicon, oxygen, and oxygen is also called sand, is also called silica.
Silica.
Yeah.
Yeah.
Okay. It's also called silicon
Okay.
dioxide. But this is not this. Wafers are just silicon. They are not sand. Okay, you got that?
Yeah.
Cool.
Yep.
So if you take just pure silicon, like absolutely pure silicon, that does not make a chip. This is not a chip. Okay, pure silicon, like 100% pure. This is not an electronic chip. Doesn't make it. You have to add something to it. Okay, what is that impurity? That impurity typically is gold element or gold particles are introduced into the wafer. Or there can be other types of impurity. When you add impurity, the word is called doping.
Okay.
And let's see, it's kind of a crazy word, doping, but that is the word. And this is created by adding impurity into silicon wafers. And you can read more here. But I'm giving you a key element to understand what is what, so you can at least get the picture of what things are coming from. So you add some impurity to make an electronic chip. The process of adding impurity is called doping. And the word comes from the fact that this slang word called dope, if you remember. Do you? Did I lose you?
No, no. Yeah, we remember. Dope. Is it about like smoking
Yeah, exactly,
dope?
that one.
Yeah.
Yeah,
Don't do dope.
yeah, that exact word. That's where it is coming from. And it is the process of adding impurity to a silicon wafer that makes a silicon wafer that is used in electronics. So when you add impurity to a pure silicon wafer, that makes a semiconductor. Now, before we talk about semiconductor, what is a conductor?
That a heat and electricity can pass.
Yes,
Electricity can pass through without it changing.
yes.
Yep.
So one that can transport electrons, that's what a conductor is. Or let electrons flow through. That's a conductor. Now what's a non-conductor? That does not.
Like an
Yes.
insulator?
Yes. It is also called bad conductor. And there are good conductors also. And there are better conductors also. Better conductors as in, good, better, best, or those things come into play. So gold is a very good conductor. And so is silver. And so is aluminum. And so are many others. wood and plastic and silica and sand are bad conductors. You got that point all the way through? Okay,
Yes.
sweet deal, sweet deal.
Yeah.
So, what is a semiconductor? That's the question. Now we know what a conductor is, and a conductor can transfer electricity in this direction and also this direction, both ways.
Semiconductor is just one direction.
Yes. So conduction is flow. Conduction is flow of electrons. And it can go both ways. And a bad conductor does not flow electrons at all, any direction whatsoever. Semiconductor will let you flow this way and not this way. You see what I'm saying? Do you get that?
Yep. Yep.
Yeah.
And this is also true. So it can basically go either this way you write, or you write like this, but not both. You see what I'm saying?
Yes.
Yeah.
Cool. So it flows current only one way, not the other way. It's a one-way traffic. Like in Seattle, you will find many roads are one-way traffic. So they let the current flow only in one direction, not the other direction. That's a semiconductor. You got that point, right? See, the lines number 12, 11, 12 are similar to line number 15 and 16, except they are reversed, like left to right versus right to left. See how the current flows in one direction only? And if you go to Radio Shack, diode, that's the simplest example of a semiconductor. Very simple example. This is how it looks like in Radio Shack. And
A
a
diode.
diode looks like this. Basically, it's a wire on both sides and a box in between, and this ring on the side here, you see that ring? This ring shows where it will let the current flow. The current will flow from on my screen as it shows. The current will flow from my right side to my left side, not the other way around.
So the silver ring is where the current flows out
Yes.
of.
Correct.
Okay.
That's a Radio Shack diode. And it's a very simple object you can find in Radio Shack for a few cents. And you can test it out. But don't when you test it, just read very carefully. It's a $2 object. You can experiment with it with a battery and some simple little electronics. You can absolutely do that. It's trivial. I used to work at Radio Shack. It sucked. Yeah, working at Radio Shack is different from using electronics, right? It's a different game. So makes sense. So let's continue. So in our Radio Shack discussion, let's see what is not this semiconductor diode. So if you look at diode, what this thing is pictorially represented like this. And a diode representation is like a triangle with a line, and this line was that silver marking that you saw in this picture, except that in this diagram the line is on the right side and the picture that we saw in Radio Shack was on the left side. In simple language, this is how the current flows and this is how it does not. You see that? The picture, the triangle shows the flow of current, and the other direction the flow does not happen. And that's the logic.
And diodes.
It's a deja vu again for me.
Nice. So these things are called semiconductors. They flow current only in one direction. You got that? Some comments. Yes. So
Check.
comparatively, in actual object versus picture representation, this is how it looks. A picture representation is on top. The actual object in Radio Shack looks like this. More
Got it.
examples here. See that line here and the silver line here is the same thing. And that's the basic foundation of semiconductors. You can see that the current flows. By the way, there is one more point I should clarify. When I say current flows, this current, let's see the current diagrams. Where are those? Yeah, here. So in this current diagram, you see that in the upper portion of the picture, the current seems to flow from right to left, right? Correct? Right to left, it flows.
Yes.
Left to right, it does not. Meaning in the bottom segment, the diode is flipped. The diode is flipped left to right, and after it is flipped, the current would not flow. Now remember this picture. I am saying the current would not flow. Now, by convention, and I want you to really pay attention, this is a very difficult thing to understand and kind of not intuitive. Not intuitive. But remember this, the flow of current is exactly the opposite of flow of electrons. So when current flows from right side of the screen all the way to the left side, electrons are actually flowing from left to right. And that is because electrons are negatively charged. And current by convention is called positive. So when current flows from right to left, electrons are actually traveling from left to right. That makes it appear that the current is flowing from right to left. It's a very non-intuitive thing to understand when you first time hear it, but remember that actually electrons are traveling in the opposite direction when the current flows towards you. You got that?
Yes.
Yeah, isn't that how they create a resistance and create electricity?
So
That's right.
the fact that electrons are moving means the current is moving in the opposite direction. That's what it means.
Yeah. Yep.
Now it's a convention thing, and people always talk about the current. However, the thing actually flows is electrons in the opposite direction. The actual object that is traveling is electrons. Anything else doesn't move. And the thing that moves is actually moving in the other direction. When you think that the current is moving towards you, electrons are flowing the other direction. That's a point to remember and understand. The thing, when people say current is flowing towards you, actually you are sending a bunch of electrons away from you. That's the concept.
Right.
It is something to understand and remember. And back to our discussion here, semiconductors. A classic example of a semiconductor is a diode. It lets for a current flow from one to the other direction, but not the other way around. That's a key thing. It's a building block of all electronics. All electronics that we know of since early 1930s, and Marconi invented radio. Since those years, 19 something, 10, whatever. Since that time, they used this element called diode to let current flow only in one direction and not the other direction, to create circuits that are electronic circuits, or let's call them electronic circuits, as opposed to other circuits which are not electronic, or they are called linear circuits. Let me say linear circuits. A linear circuit is basically a current flowing through a half conductor or resistor. So I think before I jump that, I should also describe this concept of a good conductor, a bad conductor, and there is something in between conductor which is called, I'll let you guess. What will that be in between? Yes, will it be
Intermediate.
semiconductor? Actually, no.
Semiconductor.
That was a trick question. So these are, yes,
Resistor?
they're not good, not bad. They just resist, but let current flow.
They also help you from getting shocked if you
Yeah,
hold
that is
one in
called a
your
bad
hand.
conductor, helps you
They-
prevent shock. A bad conductor will prevent shocks. Resistor will not. Okay. So resistor will not prevent shocks. Bad conductor will. So bad conductor is good for you. If you are doing electrical work, you want to use gloves. And these are bad conductors. Resistors let the current flow, but with some resistance. And semiconductor is kind of weird. It is weird in the sense that it behaves like a good conductor in one direction and bad conductor in the other direction. You see that? It is not linear. It is not normal on both sides. It's like a split personality. It's like schizophrenia in some sense. If you talk to me this way, I will let you behave like a good conductor. If you talk to me the other way, I will behave like a bad conductor. It is strange, but that's what semiconductors are in real life. They are not like a halfway conductor. They are not resistors. They are not poor conductors, but they are semiconductors. They are really good in one direction, really bad in the other direction. They're not poor. They are just bipolar. I mean, they are schizophrenic in some sense. And good conductors are wires. And this is salty water, or a good resistance will be electric bulb. So that's what
So what about graphene?
graphene. Okay, you're going way ahead.
Oh, okay. I'm sorry. We can.
You
You
just
can.
mentioned
I
about
didn't
graphene,
realize I'd be jumping in.
which is a special substance, man-made substance, and we should discuss that at some point. Not in this flow of discussion, by the way. So graphene, you should check it out. What it is
Okay.
for those who are interested. Graphene is this thing. Graphene is pure carbon, but structured like this. No,
It's from
it's
graphite,
man-made.
correct?
So graphene is structured like this. It's a very thin, it's a nanomaterial. Graphite is different. And graphite,
It comes from the residue
yeah,
of graphite,
you
though,
have
does
to
it
create
not?
it manually. Take carbon elements and create it. There is a process to creating that. This is a graphite. It's an object that is found in nature. But this is not graphene. It's mostly carbon. And a brother of this is called diamond. And this is also carbon, pure carbon. But it shines. And it's very expensive, hard to find. It is pure carbon, C. So that's what diamond is, that's what graphite was. We are not discussing graphene right now because it's way beyond the subject right now, but in this topic we are discussing about good conductors, bad conductors, poor conductors, and semiconductors. Semiconductors are good in one direction, bad in the other. Poor conductors are bad or good, or maybe kind of in mediocre in both directions. It doesn't matter direction. Direction of flow does not matter. In semiconductors, the direction matters a whole lot. In one direction they are good, in the other direction they are bad. They are not poor. They are not poor conductors. They're just either really good or really bad. So that's a distinction. You want to understand that. Now, the types of electronics are of two types. One of them is called analog electronics. This is what you will find in your music amplifiers or guitar amplifiers, if you will.
So like tube
It
amps
doesn't
and
have to be
stuff like
tubes,
that.
but just amplifiers. It can be transistor, it can be silicon based also. Tubes do not have silicon, by the way. Somebody just mentioned, I think Aaron mentioned
Right.
tubes based electronics.
Mm-hmm.
They do not contain silicon, but still operate the same way. They are older technology and they do not contain silicon. They are big.
Is that what the old computers, like the
Yes,
really, really big ones, were
old
made
ones
out
and
of?
really, really slow ones, but yes.
Okay.
And the other types of electronics is called digital electronics. An example of this is your iPhone or your computer. So now I'll go deeper into these two subjects. And most computers, almost every computer, unless it is specifically an analog computer, is a digital computer. So we will not discuss this right now. We will discuss digital electronics right now, to begin with right now. And I'll tell you how things are built up towards a computer. And then I'll further take that discussion on to what we are discussing. So if you look at digital electronics, one of the building blocks that I told you about is a silicon wafer, 100% pure. Add some impurity like gold, and that makes a
Chip.
chip. And through these chips, the way you add impurity in various locations, and amount of doping and amount of the whole layout, this concept is essentially leads to a diode at the very basic. And the way you add impurity is what designs which way the current will flow. And so that's a building block. A next building block of I think I have a visitor coming in, so give me a second. And I have two dogs, two big ferocious dogs, so I apologize. Hold on, let me take care of them.
I want a big ferocious
They
dog.
did not make any noise, so it's good. That's good. That's good.
You can actually.
Yeah. Go ahead. Keep going. I'm not going anywhere. I'm here. Yeah. Keep going, sir. Hey, there was a question.
Oh, I was only gonna ask Aaron something.
No, I did
since
not leave.
I thought you
So
were leaving.
sorry.
For a second, we're
So
good.
I'm back. The thing that I want to continue discussing, they did not make any noise, so I just kept going. So diode is a basic element. A combination of this type of elements is called a transistor, which has three legs.
Right.
And it behaves in somewhat different fashion. We are not going deeper into how it actually functions, but I'm just taking that discussion into a different direction, which is using these types of elements or constructs they construct a very large scale integrated electronic chip. And so this thing is called AVLSI, very large scale VLSI, very large scale integration. And this essentially is what you see in newegg.com and find something of interest like an Intel CPU. So you see this chip in a box that Intel sells is a desktop processor, G3258 Haswell dual core, blah blah whatever. This is the heart of your computer. Is a very large scale integration, VLSI, made by Intel, and that's what you can buy for 70 bucks and build out a computer out of it. That's what happens, right? Some of you have done it, I guess. Did you assemble a computer ever before? At least one of you did, I think. So you take these kind of elements that are
Yes.
available in stores. These are very large scale electronic chips, and these things construct various components that go inside a computer. And that was an example that I just gave you, was an Intel Haswell processor, $69. Right? You can buy it from Newegg today.
Mhm.
The no.
Is
But
that a
yeah,
good chip?
it's a working chip. It's
Okay.
$69. You will get a lame chip, but it works. I'm not complaining. It's a good price. So yeah,
Okay.
good product. Depending on what you have. So don't go buying it. Just because I pulled it up. This is not what I'm recommending. Yeah.
No, I'm not going to. I was just asking.
Chip.
I'm gonna
It's an old
put
chip.
another computer together.
Lame, slow. But lame as in this, every chip will
Okay.
become slow at some time. Today it is good, tomorrow it will become slow. And that's okay. There is a law behind it, and the law is called.
Literally today and tomorrow.
And so what is the
Literally.
law here that
Very
shows
literally.
about this decay of power? What happens is that computers don't actually become slow. User expectations go high.
Yep.
Really, really high. And that's the problem. There's also another problem is that it's called Moore's law.
Development.
Moore's law. Yeah.
What's Moore's law?
So let's see what
Double,
Moore's law
triple.
is. Moore's law.
That's
It's-
so.
It's everything. The speeds of it all will double. I think it's double
not about
every
speed.
18 months.
No,
Am I
read the law very carefully.
right on that?
What is the law? Here. It says, Gordon Moore says the complexity for minimum component cost has increased at a rate of roughly a factor of 2 per year. Let's read the law language. I mean, law, it's not a law, it's what Moore said. He was an Intel chairman, I think. So let's see what the law is. Yeah, the Moore's law is an observation. That is the correct definition. Let's pull it up in Notepad and paste. It is the observation that over the history of computing hardware, the number of transistors in a dense integrated circuit doubles approximately every 2 years. That's the law. Okay. That's right.
So it's
That's
just what
right.
they're
That's
able to
right.
produce
Every 2 years,
doubles every 2 years.
excuse me.
That makes sense.
Every 2 years, approximately, the number of transistors in an integrated circuit doubles every 2 years.
That's incredible.
Now this law
Well,
not
has it
really.
has continued to do that?
It has, no, it is not happening.
Because you
anymore.
can't really you can only get things so
This
small
law
and
is history.
so compact.
This law is not valid anymore.
Okay.
It's evolving into a different type of law, and the law is called.
Okay.
These are all, by the way, not laws. These are what people make up. The observations.
Observation.
But this is the new law.
Yeah.
And this is the new law. Let's see
Based
what
on
it
what's going on in society and electronics.
is. Yeah, the Bezos law is
Bezos
kind
law.
of different. But Moore's law gives way to Bezos law. Let's read what that law is. And the law is, where is it?
I don't know. He's got a line going through his face, though.
He is such an
guy?
intense dude.
This guy?
The guy
yes.
radiates intensity. Jeff Bezos,
Yes, he
yeah.
does.
Oh,
Yep.
that is Jeff Bezos, isn't it?
Yep.
Brilliant
And by the
man.
way, I
Absolutely
understand he
brilliant.
did not go to school or something, right? Did he?
Nope, he was he went to high school but did not
Remember
go
that.
to college.
Many smart people that have done it.
My hero.
Yes.
Look at Richard Branson. He's a high school dropout and he's sending
That's
freaking
correct.
airplanes to space now.
Mhm.
It's amazing. Love it.
Yep. So here is the law. Let's read that. So we saw Moore's law. We'll do a compare and contrast of the new law. Moore's law was the observation that they double every 2 years. And this new made up law is called the Bezos law. Both of them are made up, but that's how things happen. Is the observation that over the history of cloud, a unit of computing power price is reduced by 50% approximately every 3 years. And so it changed. What it is evolving into is economics. So these words are called law, but if it is really like a law like Newton's law, they will hold true perpetually forever, right? So they're not really laws,
Forever.
but they are
Yeah,
observations.
so they're not really laws.
They're called laws to make it sound interesting, but they're not really laws, they're observations. Because a law means, it holds true. Holds true like Newton's law. That's what I think a law is in science. Newton's laws of physics, they hold true no matter what. And it has been proven to hold true no matter what happens on the planet. It will still hold true. These are fundamental laws. They will not change.
My shoe will still
And
fall.
these are just observations. I don't call them laws, but people seem to do. So understand that they are calling it a law, but it's not really a law from a science perspective. It's more like observations. So these are the two observations Moore's law has given its way to this new law, is what this particular writer is claiming. And he's a respected writer, and just understand that. So having said, let's continue back. What's our discussion is about? Is about
Diodes,
building out
semiconductors.
components to build a computer. What are those components that we need? Do you know? What do we need to build a computer?
Silicon.
A
motherboard?
Processing unit.
A motherboard. Cooling.
Cooling unit.
What else do you need? Wires.
You need wires.
Power.
Power. Yeah, the power unit. Possibly some sort of you need some sort of hard disk, whether it's solid state or not.
Memory.
Yep. Oh, RAM. Yeah. Good point.
So memory, why do we need that? Why can't we use the disk that we have for storing stuff?
Because it's random access memory. It's quick. It's fast. It's always available.
It's temporary
It's a
memory.
temporary storage, yeah.
It's like long-term memory and short-term memory, essentially. That's how I understand it. It's fast and fast.
When I say it's relatively small, we are still talking about gigabytes of RAM, by the way. These days, RAM is also cheap, so people just add up. Typically, computers people buy with 8 GB RAM comfortably. It's very easy. And hard disks anywhere between say 500 to 500 GB to a terabyte, 2 terabytes, 2 TB. It's very common these days to get large disks. Or if you're getting SSDs, it is common to get like a 128 GB SSD or even 1024 SSD. That's also common these days. It's available. And even larger 32 GB RAM is also available. So you get some RAM, some storage, some disk space, and what else do we need for a computer to run correctly?
A
Do you need a
monitor?
monitor for a computer to run? That's right.
No, not really. Just to see what it's doing.
Video card, yes.
Ah,
Right.
but that's only if you have a monitor.
And so you need
So you don't really need a
correct
video card
for
either.
a person to interact. They need to see, and so they need a video card, and that's how the monitor gets hooked up. But if you're not seeing the computer face to face, it will run without a video card, without a monitor, if it is in the cloud or away from you. You can actually not have a video card at all and still run it
Yeah.
in a server configuration. If it's a user computer like a desktop configuration, you need a monitor and a video card to see what's going on. Otherwise, how will you find out? What else do we need?
A containing
Yeah.
unit of some sort. The box.
You can use a milk crate. Nothing prevents you from using a milk crate. Yeah, I do it.
I'm totally gonna do that.
That's the reason, if you remember me discussing about Bitcoin, it is actually put in a milk crate
Bitcoin?
because it is
I knew you were
hard to
gonna
cool
say
it down,
that.
right? So open air
It
milk
gets
crate.
so hot.
What else do we need?
What about using just a one of those? I
Yes.
saw someone use a fish tank where they stuck the computer in the fish tank with oil around it.
That oil is
So
really
ventilation is
expensive.
important
Is
to
it?
cooling. So you can cool
Well,
through
depending on the
oil,
model.
you can cool through water, cool through air, but ventilation of cooling is important. So that's where it comes in. What else do we need?
If you want a one of these things, camera,
So it's kind of like a video card, except the other way, right?
USB ports,
Yes.
logic.
And
Well, the logic
this
port is the
is
motherboard.
a camera.
So
Conceptually very similar to what you will have in case of a speaker and a microphone, a monitor and a camera go together, right? So video input.
yeah. What about like USB ports, that sort of thing? Connection.
Input output ports.
Yeah, there you
Input
go.
and output ports.
Internet.
Input or output
Yes,
ports are, by the way,
good point,
built
Han.
into your motherboard most of the time. So you can get, your motherboard contains these things already.
Yep.
Similarly, motherboard also contains these in video card already. And motherboard also contains video and sound cards already. Motherboard also contains place to put RAM, a place to connect hard disk, and all the wires. Usually the package comes along together. We also need something that somebody mentioned, USB ports. They are, by the way, part of your motherboard mostly. You can get extra from externally connected, but they are usually comes along with the motherboard itself, will give you ports. What else do we need to build a computer?
Ken said the Internet Wireless
Yeah, the
Receiver.
big black box is called Power Supply Unit, PSU.
Mhm.
The big black box. And what else do we need to build a computer?
you need the knowledge to assemble it.
Yes, correct.
Guess what I was gonna say.
What else we need?
You need the oh, you already had the processing unit. Never mind.
Yes,
Need an operating system.
you need an OS.
Yeah. Yes, you do.
What else do you need?
Mouse, keyboard,
They are called
peripherals.
peripherals. Peripherals. Anything that goes along
Peripherals.
inside a computer, like outside the computer, but works with the computer, like keyboard, mouse, printer, scanner. Yes,
Steering wheel.
gaming devices, like steering wheel and whatever else. These are called peripherals in general, and they are needed so that you can interoperate with the computer, have it do interesting stuff. A printer can be a 3D printer or a 2D printer, like paper printer. You know what a 3D printer is? Have you seen that?
I want a 3D printer.
It is cool.
Oh yeah, they're amazing. They're so awesome.
I would love to get one.
Those are going to
They
revolutionize
already have
manufacturing
already done it.
completely.
Yeah.
Yes, it is.
What else do you need in this listing? Yes,
A user.
that's what this thing comes the know-how.
Let's see. No. User with know-how.
What else is missing?
I just saw the internet stuff that can.
Yeah.
We don't have that up there yet.
Network.
Network.
Hi, Brandon.
All right, I'll see you guys later.
Later, Brandon. Peace.
Yeah. Let's see who we have in the class right now. Okay. Okay, we have good number of people. So I think we are recording it. I'll make sure to share it with everybody. And let's continue.
I'm totally gonna download all the classes and all this stuff and just compile it.
You don't have to
That way
download
we
the
can go back and
document
have a
file.
reference.
You should be able to continue access it wherever it is kept, and no worries. So,
Okay.
did we miss anything to build a computer? Like optional things like Bluetooth connectivity.
Yeah, Bluetooth maybe. Yeah. FireWire.
Me?
I don't know who uses that anymore.
Yeah, I have older
Really?
hardware, older hard disks that connect through.
Okay, older hardware. Yeah. Remember they went to the
Yes.
FireWire 800 and like I never found
I have
anything to use it.
FireWire
Use it.
800. Thunderbolt is
crazy.
another connectivity option available for Macs.
Right.
Stephanie
and that's
says.
antivirus.
Somebody's.
Yeah. Unless you're using a Mac.
So, yes, if you
should still have
Mac,
something.
you still get viruses. You can get viruses. There are Mac viruses.
So what should you use on a Mac?
Talk to you about
What would you
that.
recommend?
And antivirus is a software.
Okay.
There are other software that we need. So antivirus is just one type of software that you need to have on your computer. Yeah.
Maybe a word processing.
Generally call it collaboration, creation, collaboration, or productivity suites. Productivity suites of software. And that in that we will create document creation, spreadsheet creation, presentation creation, and keep going like that. Right?
Okay.
What else we need?
Mm-hmm.
Nilesh, did you see Trevor's comment?
Is there a good free antivirus software for both PC and Mac? There is no such thing that will work in antivirus on both Mac and PC at the same time. However, if you're using Windows, here is a good one. No.
Windows Defender.
Windows Defender. Yeah, Defender is built in.
I just use
Built in.
Defender.
Defender is
That
built
works
in.
pretty well for it.
But Microsoft has a very good product for Windows. Microsoft antivirus. This one is a good one. And you can install it. It is free and it actually works nicely without bogging down your system. And a word of caution comes along. A word of caution. Caution is the real caution here. The caution is do not use two antivirus software on one computer.
One.
That's a caution. It will kill your computer. Yes. Uninstall the first one completely. Reboot and then install the new one. That is a caution. Antivirus software works in a different fashion than most other software. It creates a layer on the file system, and you can cause trouble by creating multiple layers of file systems, multiple layers of antivirus software like this. So it's a word of caution. Remember, more antivirus is not a good thing. One good antivirus is a great thing.
Okay.
This is a good one.
It's like trying to double up on condoms. It's not. It doesn't work.
Okay.
Never use two.
Wow. Okay. Okay, leave that topic, please.
Man.
Okay, let
Trevor says, do you know first aid?
I'm a medic, Trevor. I'm supposed to know these things.
Good answer. Let's continue.
Always keep your battle buddy safe, right?
Battle buddy? Okay, don't get me started. Okay, let's close. So these are the things that you would need to put together a computer. Now let us look at what things we do not need. The distinction between need and wish that I had. Let's clean that up. Okay, what do we not need? I'm saying need to run it in the cloud. What do we really need? Yeah,
We don't need
you
antivirus
might not
software.
need, and I would agree. You know,
Or-
don't need it.
or-
Yeah, you can.
Or
strike that.
productivity software.
In fact, you don't need all these things. You might need for a specific application.
Software.
Yes.
You need your OS because that'll have your terminal,
Yeah, you need
and you can
just
do all
enough
your
OS.
nano and stuff from terminal.
Just the bare minimum was to get the machine started and connect to it. That's what I'm thinking of. So yes, you need an OS of some sort, just enough to
Right.
get it going. So I'll call it JEOS. Do I need peripherals? Yeah, it's a real term.
Is that a real term? That's good to
Disk
know.
for storage. You still need a disk for storage
So
but
this
you just need a really
JEOS is
small
a
disk.
Wikipedia term, and I think
Like-
Wikipedia is a pretty darn good one.
Yeah, well, that's good to know because I don't want to just like use it every day and then
So I think it's always
sound
a good idea to
ignorant
just
if I'm
quickly check Wikipedia
if
and see
it's-
what people
yeah.
are talking about it. It's called Just Enough OS, pronounced juice. Not many people know this. Not many people know this, by the way. So yes, you may
Oh, that's
sound
right.
weird when you say that, but always go with a reference. I did.
I think you mentioned it actually.
In fact,
Or
there's a
need
write-up
some
here
juice.
called Get Juiced.
Yeah.
And so these things, you know, you keep
knowledge.
searching, you'll keep finding, and yes, it is a real word, juice. And so you need a juice. You need juice. Good. What else do you need? Do you need gaming devices in the cloud? Let's knock down these things. We don't need like peripherals, mouse, keyboard, printer, scanner, gaming devices in the cloud
No.
computer. No, you don't need. Do you need Thunderbolt and FireWire and Bluetooth? No. Do you need Wi-Fi in the cloud? On the machine in the cloud? Not really.
No.
Now you
No.
need Ethernet, the one with wires, and you can probably do better than Ethernet, called either Gigabit Ethernet, like faster Ethernet, or even better than that are available. Like one of them is called InfiniBand. And there are newer technologies coming in that space. That's what is used in connectivity, and there are other ways of connecting. So, but you definitely need some form of connectivity. That's needed. You need cooling, absolutely yes. And yes, you need RAM or memory, indeed. You need some disk for storage. Yes, indeed. What else do we need? Power supply. Yes, yes, that is needed. Do we need wires? Indeed. Do we need USB ports? No. Do you need sound card? Not really. Video card? Not really. Input and output ports? Maybe. Yes, they might have it. Most computers come with it. But you are not going to connect your keyboard directly to a cloud computer. Yeah, so probably not.
Just enough.
Yes, there is a motherboard, and the motherboard probably has a built-in CPU, and so correct.
So we're talking about
And
the
so
actual
if you
cloud
put these
computer.
things together,
Okay.
let's see. Oh, cloud computer. So last time there was a mention of this. Somebody mentioned the classroom. What was that thing? The little thumb computer. So this is a full computer with HDMI port and USB.
What?
It's like a thumb. It is called Raspberry Pi.
That is awesome.
Yeah.
Oh yeah, I've
So
seen
I
that.
think I have it somewhere upstairs. My son was playing with it. Yeah,
I was
but
wanting to
think
get one of
you
those
should
for my
play with it
son so he
first
could
before
play
you give
around
it
with
to your
it.
son. It's a $25 computer.
Okay.
It has almost everything you can think of, like a network card,
Okay.
and HDMI output, and USB, and power, and things that you can. So you can run Linux on this comfortably. Raspberry Pi, and yes.
So you could
very
install
small. Yes,
Ubuntu
not
on
only
it.
Ubuntu, but even smaller than that, I think you can install. So
Okay. I forget why I was looking this up, but
yeah, but before
they
you
seemed
buy,
really
make sure you read and
cool.
understand what you're buying. And yes, it's a good buy. It's a very good purchase to understand
Yep.
and learn. But this is just like the bare minimum these days. The whole computer is on a chip, right? It's called computer on chip. Total computer is built into one single silicon integrated circuit, including everything, like the whole thing. Computer on a chip, system on a chip, computer system on a chip, not just the CPU, but the whole computer on a chip. It's called SoC or SoC, system on chip. It contains everything you need to make it all on one piece of silicon. That's a SoC. And your iPhone or Android is probably almost like a SoC. It is actually this one. ARM system on a chip. And to be precise, it is the A8 Apple chip. So it is this chip. So it is a system on a chip that you have on the iPhone 6. It is a complete computer. First introduced September 9, 2014. Apple A8 is a 64-bit system on a chip, SoC, designed by Apple. There are other people that design SoCs, and not Soccer World Cup, but SoC. Hold on. Oh, don't tell me I need to give my computer some breathing time. It is giving me a spinning circle. Okay, cancel. Okay, SoC. Enter. Yeah. So SoC will bring you to system on a chip. There are at least two major types of systems on a chip. One of them is, what was that ring about? Somebody ring a bell, or was it just me? I don't know. So the two types of SoC, system on chip, these are the Intel variety, or even more popularly the ARM variety. These are two commonly used systems on chip. And
The ARM kind was which kind again? Was that
ARM
the
SoC.
that was the Apple?
So an ARM SoC is
Okay.
ARM is actually a consortium. If you look at what ARM is a
hmm
ARM. Is it the right site? Let's check. Home page. I think it is the right site. Yes. So this is the ARM.com is the organization that many partner companies join to construct a common architecture for computer systems which are very low powered, consumption, and Intel is also coming out with low power consumption. Low power consumption is a good thing because it uses less battery and gives you longer time. That's why low power is more interesting than high power. I mean, it is very powerful, but it consumes very low energy. The way to think about actually is not power, but say energy consumption. Low energy consumption is the way you should think of SoCs. An ARM SoC is actually very nicely done. Most Androids and most iPhones are ARM SoC. Apple has a license from ARM to produce its own A7 or A8 chips from Apple. NVIDIA also has a license from ARM to produce their own chips, and so has Qualcomm, NVIDIA, and some other companies have licenses to produce ARM-based chips. And Apple bought an acquisition company. That's how they got the license to make these ARM chips, and they are making the latest one being Apple A8 chip. And the other competing game is from Intel, and they have their own SoCs, and even AMD has their own SoCs, if I remember. So these SoCs are really what is being used in mobile devices and also in the cloud computers these days, by the way. There is a company which is making ARM based servers, and here Calxeda is one of the companies that is making ARM servers, to make a serious threat to x86 server domination. So the news here is Calxeda is the first ARM server maker to serious threat to x86 server. So when Intel makes something, they call it x86. When ARM makes something, they call it ARM. And the way I should write this is like this actually. Yeah, that's a better way to say. So there are two types of SOCs in the industry. One is x86 type architecture and the other is ARM architecture from a system on a chip. And these are the makers that are making it. So this is used in iPhone 6, for example. And this I think is using in, I'm not sure which one Samsung uses. Samsung, what was the name of Galaxy 5 processor? What is the processor there? Let's look at that. It'll tell you what processor they're using, and the processor being used is here. So Samsung, what was that phone? It was called Samsung, what was the name of the phone again? Galaxy. Yeah, Galaxy. It uses Qualcomm's Snapdragon system on a chip. Windows Surface RT uses some NVIDIA ARM chip. Windows Surface Pro uses x86 Intel chips. And so you need an operating system the OS for ARM is different from the OS for x86. Sometimes these are also called x86-64. And this 86 actually means 32-bit and 64 means 64-bit. It's very strange, but remember that x86 is 32-bit processing. x64 is 64-bit processing. It is weird.
That's weird. Nilesh, real quick, what program are you using to record all these sessions?
What is it called? This one. What's the name? ScreenFlow. I typically use ScreenFlow. I will typically
Screen
use
what?
Hangouts for recording. At this moment, yeah, automatically gets recorded, so you don't have to worry about
Okay, so you can record in Hangouts.
And this is not Hangout, so we're using a special software to make it happen.
Okay, cool.
Now, in these two, there is ARM32.
Okay.
ARM32, ARM64, both are possible. And even smaller, in older days, we used to have 8-bit processors. So when I was studying in college long ago, I used to have 8-bit computer. And even before that, like hundreds of thousands of years ago, we used to use a 1-bit computer, which was like yes and no. The ability to say yes and no actually is a 1-bit computer. If you do not understand that, let me help you understand this. Yes and no. Saying yes and no is a 1-bit computer. It's
Is that
trivially
just
simple. That's what it means, and it actually is nothing to do with SOC, nothing to do with ARM either. It's not even a computer. It's just a button to say is it on or is it off. That's a 1-bit computer, and all you can do with it is say yes or no. That's it. It's like a flip switch. You can turn it on, turn it off. That's a 1-bit. You can make it a more complex machine by adding more bits to make it do a little bit more complex things. And these days, most computers are 64-bit. Even Apple A8 is a 64-bit chip. And so are these guys. So most people are now these days developing 64-bit computing. And remember that you need a different operating system binary altogether, a completely different download for ARM, which is different for x86 64. Partners, Ubuntu page not found. What's wrong with you? Yeah. So this binary is for Cavium Thunder ARM v8 development platform, and this is for Marvell Armada XP platform. And so you can get the download from here. You just register and then you can download it. This is a different binary for ARM type architecture. Alternatively, you can download the x86 version from here. Two different types of operating systems compiled for that architecture. One is ARM architecture, the other is x86 architecture. Different industry players play in different segments. Sometimes they play in both. Like Intel had a ARM based license to prepare and create those chips, but for some reason they sold it, and they probably they feel that it's a bad decision that they did, but that's a business topic. From a technology understanding concept, there are these two major architectures available in the industry, and for operating system you need a Windows RT to run on ARM, and Windows that you know will not run on ARM. Windows RT will not run on x86. You need, it's a different animal.
What is Windows RT? That's
Yes.
okay. Never heard of it before.
Not tablets, but
That's
specifically
what they use for their tablets.
Windows Surface RT. That one. Not any tablet. They have other tablets called Surface Pro. I think the name is Surface Pro, as opposed to Surface RT. So let's see, surface.com. Let's see what we have there. So on surface.com there are two product sets. One of them is, what did they stop selling Surface RT or what? Yeah, they're all selling Pro. I know, that's the one.
It was their original that flopped.
Selling or what? Let me go another search. Surface RT. Yeah. Yeah, this site is slow. Yeah, is it RT? Yeah, it is RT. And how much is it? $299. And you can install nothing on it. Like nothing.
Not bad for a tablet.
Because all you get is what they give you.
Yeah.
Yeah, you're mostly stuck on this machine because they.
So you're stuck. They use the magnet. They use the magnet charging like Apple.
So
there's a reason they released
RT
the second
tablet.
one within 6 months.
You cannot install your regular Windows on it. You can do literally no installation at all, except unless you go through the App Store. They have an App Store here, and that's the game here is locked down. It's totally locked down into what they want to control. They'll give you Office and everything, but it is what you get. That's what you get.
It's just like
slow.
It's very integrated.
And so if you look at the other tablet,
And
it's
slow.
not slow. It lets you install whatever you want, and this is a regular Windows computer, but it's a tablet. And so this is very, very similar to if you go to Amazon.com and buy a computer. you can get any of these computers that you can think of. They're all x86 computers most of the time, almost all of the time, unless you're buying a phone or a tablet, in which case it is probably a SoC, an ARM SoC, as opposed to an x86 machine. And those ARM SoCs are Android tablets, and let's look at that, what we have in the market. So if you go click on laptops, they're typically Windows computers, like these. You can see them. They're all x86 and running Windows. And sometimes you see occasionally Mac showing up, but this is also an x86 hardware. So Macintoshes are this regular Mac. We call it what's the machine it's called? MacBook. Yeah, I don't call it regular Mac, but call it MacBook Pro, MacBook Air, iMac, or Mac Pro. These are all regular x86 64-bit architecture using Intel chips. As opposed to the iPad, which is this. So you get the idea on the two different architectures that we have in the market. Most of the machines that you know of are actually 64-bit, the x86 64 that you see here. If you keep looking for tablets and look at tablets, the majority, the bulk you will see in the market in Amazon or eBay or wherever you go will be Android tablets or Kindle Fire tablets or iPads, and they are all ARM architecture, ARM. So we just finished our discussion on the client side of computing as to what we have in the market today. Now let us change all that into a server side. And I just briefly mentioned to you is this idea that server from Calxeda is the first chip coming out for server deployment. And HP server, Dell servers are very popular if you look at, and then there are others also, huge providers of servers. So if you go look at the market, server hardware, what do we get? You get Dell, you got HP. Who else is selling? IBM. Who else is selling some hardwares? And so on top of these server hardware platforms, you will install some server operating system to create a server, essentially. And the dominant usage is not ARM yet. It is this. That's the dominant today. The ARM will come, but not there yet in big time. Most of it is x86 based servers. And if you look at specifically what gets deployed in the cloud, this is how it looks like. Let's see what the picture comes. So here's a VMware example, and there are racks and racks of stuff loaded like this. Have you seen pictures of things like this? So from a wiring perspective, it looks really ugly, like this. really complex type of wiring. But from a deployment perspective, let's say, what's it called? Semi. Yeah. So here, look at this. This is a picture from NASA, and what they are doing is, let me make it big. So see that the truck and a trailer contains this object called nebula. You see that? And that is a box. It's a huge container box. Inside, all you need to do is mount it in a building, side by side many such containers, and that constitutes your cloud. This is manufactured apparently by Cisco. If you look at the brand at the corner, Cisco, and it is deployed Nebula, which is an open source project by NASA. It's part of OpenStack.
So Nebula is
Let's read what Nebula
a
is.
cloud server, essentially.
Nebula.
A cloud in a container.
So Nebula is a federal cloud computing platform originated at the NASA Ames Research Center in Moffett Field, California. These people did it. It is free and open source software. And now we have it called Open Nebula as an example. Another variation of that is OpenStack. And OpenStack is an open source software that enables cloud computing for big name companies and big name organizations, and the names are NASA and Rackspace together started working on this project that is now deployed in major cloud companies such as HP Cloud is a big name, Rackspace is another big name. They use this software open source, contributed by Rackspace and NASA together in 2010. And all these major companies that you see listed here use that software. But from a hardware perspective, it looks like this, like I showed you the picture of hardware. I'll do one more search for you so you can see more pictures and understand what that thing actually looks like. So if you look at this picture, this is actually a Microsoft picture if I remember right. And it's a container, and yes, it is Microsoft container all in one cloud. So you basically bring a truck with a container on top and you connect it with cables and cooling, and you have a cloud up and running. Let's look at more pictures to get you perspective. So here, see the guys can walk inside, and it's well contained. Well structured, well laid out, and you can actually see if you go to Microsoft building outside, one of these guys is sitting there. You can see that if you want to go there, and I can take you there outside, and not inside. I can definitely show it from the outside. I'll go check first before I say further. I'll go first check if it is visible from outside. We can go take a look.
Let's just go build one at RP6.
Or rather, use it. Use one of these guys from a remote location. So these things are connected to the internet, and we can rent them. And we already are doing it occasionally when we use some services. But this is what exactly is laid out side by side in large numbers, racks, floors and floors of buildings full of these things that mounted like this to construct. And you can put multiple of them side by side to construct a classic layout. And this looks mobile in terms of very easy to take it from one location to the other, but the idea here essentially is to make it almost like repeatable. So you have boxes that you line up, stack side by side, and something goes wrong, you just take one of those out and put a different one in, and you're back in business. You just throw away the old one. That's the idea. So when something go wrong, you just remove that element, put a different one in place. The whole box goes, and somebody else will fix it or throw it away or discard it, recycle it. And you just put a different box in its spot and you're back in business. That's the idea underlying. From a usage perspective, you don't want to waste time in repairing and fixing. You just stack them one on top of the other like this. And this is an example of a Chicago data center. And if you visit the page, you can read more about it. It's a Microsoft from containers to modularity. And so you take a container, put it on top of one another, and build out a cloud infrastructure for you like this. And you can do it in large buildings. This is a Microsoft Quincy data center, apparently in Washington. A picture of that. Now, from a usage perspective, if you go back to our discussion here, these companies seem to make that computers that go inside in a rack. I'm not sure if you've seen a rack or not, but I want to show you a rack server. So these are kind of blades. Think of it as a blade that you rack up side by side or up on top of each other to constitute a full rack. So think of a blade that goes like horizontally from here to here. That's a blade. The height of this is called 1U. So the definition is 1U is the height. It's about like say 3 to 4 inches. We can actually measure what the 1U height is. 1U height is how much? It's 1.75 inches. That's the height of a 1U means. So it's called a rack unit height. And this is a 1U height, this is a 2U height, it's a 4U height is half rack. And you can constitute racks like this by stacking up items on top of each other, and each blade is about at least 1U high, and that contains a full server computer hardware. Yes, yes it is. Yes.
So this is
Rack
a
unit.
universal measurement
It's called
that
1U,
all the
2U,
companies abide by?
4U. That's a very, it's commonly used configuration. It's a unit of measurement. It's called U, rack unit. And
Awesome.
the blades are actually constructed like this. Blade server. The blades server is a stripped down computer with a modular design optimized to minimize the use of physical space and energy. That's a blade server. It looks like this. And so you take a blade out and you stick it in, and on the back side there is connectivity already. It's called the back plane. The word is back plane. Like motherboard will have a card that you can mount on top of on the motherboard. So this is a backboard or a back plane where you can mount blade servers. So you literally hold that blade in your hand like this guy is. So imagine that he's holding that blade in his hand and then inserting it into the computer like this guy. Imagine this guy is inserting it, or maybe this guy. Yeah, he just pulled out something from that outside the rack. And let's see, look, this guy is doing. He's pulled out something else out of the rack. But essentially, these are blades either mounted vertically up from top down, and see you can count the blades right now here in this picture, and you can see the blade coming out. See, this blade has come out, this one, and there are other blades, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blades, and this was the 11th blade, and there are 2 more probably on the side. So you can have multiple such blades mounted vertically like this. or mounted horizontally, depending on how the design is, and essentially construct a rack full of blades. And this is a example of a 7U high versus a 14U high rack mount. And you construct these racks that look like this, and this is a full rack. And then you lay these racks side by side, or even the newer ones actually bring a full container full of computers and everything needed to make it work, cool, and keep it running, all inside a container behind a truck. Like you saw, the truck and trailer combination, semi-truck trailer combination. And then you use those, or the newer modular data centers. These are the old ones called rack-mounted data centers. So you put these guys side by side, and more of them to build out a complete data center, to make it cool. I mean, not cool looking, but keep it cool and keep it running. Supermicro is another big name that makes these kind of hardware. Supermicro is the name of the company that makes Super Rack. Just Super Rack is it's a rack. They call it Super Rack, but it's a rack. So that constitutes what is known as a server hardware. It still doesn't run anything unless you put a server OS on top. So on top of these server hardware, you need to put a server OS. And the server OS can be, classically Ubuntu, or call it, generally speaking, Linux server. Ubuntu is just one variation of that. Ubuntu or Red Hat is another variation. Now SUSE is another variation. And there are lots and lots of Linux servers. You can create your own. Windows server. Is one example. You can also run Mac server. That not many people actually do this, so I'm going to ignore that. These two types are very common and commonly used as server operating systems. The expensive.
Why don't they use
Linux server is free.
Mac server?
Is not free. Sometimes free.
Okay, that makes sense. Right. And there's really what would be a reason that somebody would have to use a Microsoft server?
Microsoft doesn't have a Macintosh server.
I mean, not Microsoft, Mac
Apple
server,
has.
Macintosh.
Apple has a Mac server.
No, a Mac, Apple server.
So
What would be a reason that they would actually have to
Apple
run
Mac
that?
server cloud. So if you need specific own your cloud Mac, yeah, they just use Mac because the license require you to use Macintosh.
Okay, just to actually
If you read
use
the
Mac.
Apple license agreement, they require you to have an Apple label
Okay.
on the Mac, so the software license agreement requires you to.
Right.
I think you should check with your attorney.
So as long as I build a computer and put an Apple on it, I'm good.
So check with your attorney as to what that is, but yes, the idea is to use either Linux server or Windows server. And when I say Windows server, I do not mean Windows 8. Not Windows 8. Not Windows 10.
Yeah, I was gonna say, there's a reason they had to skip Windows 9
People
because Windows 8 was so
Windows,
bad.
Every other release is going to be bad. And so like Vista was bad, and then 7 was good, and then
It's 'cause they're
8
not
was
used to it yet.
bad, and then 9 was supposed to be good, but they skipped it. That was a bad
And
job.
then they get used to it, yeah.
I don't know.
Well, you know why they skipped? You know why they skipped it and went right to 10, right?
Aha.
Because Windows 7, 8, 9.
Nice one. Nice one.
Hey-o!
Knee slapper.
Me too. And so,
It's so silent when you go
yeah,
on mute.
I need
It's
some
weird. I feel
interaction, otherwise
lonely.
I get quiet. Let's see, do we have people or I bored out? Do we have people or they bored out already? No, we have them. Okay, nice. I thought I bored
That'd
you
be a
out
first.
with my monologue. It's a never-ending monologue. Almost. Trevor says almost. Bored you out?
I'm
Yeah.
gonna take a coffee
So,
break. I'll be right back.
do you want to go?
You can watch my
Do you want
cat.
to continue along in this direction, or you're feeling really bored?
No,
I want
it's
to
good
quickly check.
information.
It's
A lot of
already
these are questions I've wondered. A lot of these are questions I've wondered, and I feel like if I have an overall idea of what we're learning, it kind of helps me. What you're teaching right now helps me with what we teach on Tuesday and Thursday nights. It's
I thought we
helpful
are
for
going
me
to see the
to
big
get the
picture
overall
or to
picture.
all what we are learning. Yes, indeed. So I'm not done yet. I'm not done yet by any stretch of imagination. So I'm just not even halfway through. So I think I will have to continue this discussion to build it up from ground zero, which is, the periodic table of elements. So we're just approaching the hardware. Now we will build up the discussion on software. We just described to you, Trevor. Trevor is asking, I thought we were going to see the bigger pictures to all what we are learning. And yes, we are not there yet. It takes time to build it up. I want you to get a perspective on where the hardware is coming from and how do you put that together to then now add elements of software and then think about what we discussed up until now. So the discussion that I had up until now was even before the class started. So I want to make sure that all the dots are covered, make sure that all the missing elements that you may wonder about are covered and addressed to build up from that front. So the next topic I want to now discuss is to help you understand where software comes into play and how cloud is being used. And that recap starts now. It might go beyond 12 and I hope it's okay. If it is not okay, we'll break into another part.
I have a meeting that I have to be at
Okay.
1
So
p.m.
we
in
will
the
start,
mall,
do
which
it
is
again.
about
No
15 minutes
worries.
away.
We
So
pick the time.
rush out. I need to be done by
Let's do
12,
this.
12:30
I
at
do
the
not
very
want to take
latest.
time away from the class that we have, but I think this is important and we will do that. Another time you decide. Maybe in the train ride tomorrow. No.
Okay, I'll go. Is anybody moving? Is anybody going on the train
Take the
ride
time
from
right now.
Tacoma that we could
I
carpool with?
completely lost out. Okay, it's already.
I live in Chehalis, buddy.
I know you do, man. There's no way we're carpooling. Actually, Nilesh, if you're going down I-5,
We see the
could I
direction.
meet you
So
and
hold
carpool
on.
with
This
you?
thing Monday works. I don't know what means Monday works.
Okay.
Give me a second. Hey, what is the time right now? Is what I'm going to check. Is it 12?
I already wrote in his card,
Almost
Trevor.
12.
It's nice.
So I think what I want to do is build up until now. What we have is
It's
the
11:51.
hardware
Yeah.
part of our discussion. The next topic that gives you the complete picture, which will be the software part of our discussion, is not done yet. Yes, it needs time. It needs time. It needs deep discussion, and I want to not make this session 4 hour long. I can talk for 12 hours non-stop. And and so I don't want
It's
to
a
bore you to
talent.
death. I can't.
That takes
I
a
have
lot of
this-
talent.
this,
Yeah.
It's good though.
ability to bore people with information. So I don't want to
Knowledge.
I don't want to flood. I will do it again. Whenever you decide, you need to decide, and just remember that I have a class on Mondays in the evenings, 4 to 7. So we can do it after that, or before. Before is not good. After is good. Your choice. Wherever we stop today, could we continue? So I think let me just pause our recording. Hey, Hey, let's continue our discussion. I just am going to
We
pause
do it
my
at 8
recording,
on
otherwise the
Monday. I
recording
wouldn't
file
mind
really
8
becomes
o'clock on
very
Monday.
big. And so I want to pause that, pause recording, stop recording, and then continue our discussion on tomorrow. So stopping recording now.